Hello everyone, I'm Stas and welcome to my new TouchDesigner tutorial, and this one would be a little bit different. It involves some mathematics, but don't be afraid, it's not too much. And we're gonna talk about conformal mappings. About 2 weeks ago I found this term conformal mapping and was really fascinated about the possibilities it gives to you, and played with it for a while. And if you're one of my Instagram subscribers, you probably already tired of such kind of effects. But I think it's very interesting. It's hard to create the same kind of effect with different tools, or at least I don't know how, and it's very versatile. And I show you different examples a little bit later. But first, I need to talk just a little bit about the mathematical background of this conformal mapping, or it's also called nonlinear transformation, or log polar mappings, or I don't know, many names. Complex numbers. Maybe you heard and learned about it in school or in university. I don't know. I will remind you just a tiny bit. It was invented by mathematicians about 2 centuries ago, and they come with the idea that you can create a number, some number, let's call it x, so the x squared would be equal -1, because if you think about it, normally no one normal number can give you -1 when squared, like 1 squared equals 1, 2 squared equals 4, -2 still equals 4, and it's always positive. So they just made up a whole thing and call it complex numbers. And complex numbers consist of 2 parts. The real part, sorry, my writing in Paint, it's not very good, but still. And imaginary. So the complex number is something like 2 plus 1i, where 2 is a real number, which absolutely like normal numbers we have, and this 1i is this number that multiplied by itself gives you -1. So it was called later, when it was invented, they called not x but y. So I squared equals -1, and for example 2i squared equals -4, and -2i squared equals 4. So it's very crazy kind of numbers. So that's why they called imaginary, probably. And it could be a pure mathematical fantasy, but actually it become really handful in many areas. And we would look into this actually core technique of this tutorial. Let's create a normal 2-dimensional plane, but instead of x and y, we call it r and I. And we will represent our complex numbers in this 2D plane. For example, if we have a number 2 plus 1i, it would be here like 1, 2, and here 1, so it would be here. What it gives you, you could represent all the transformation and all the mathematical functions of these numbers in this 2D plane. For example, if you have y, I squared equals minus 1. So if you, let me choose another color, if you have the dot here represents I, if you can put it as an argument in function f x equals x squared, so I squared equals minus 1, so it goes here on minus 1 spot. And you could see what happens. This transformation, multiplication, square, divisions, logarithm, exponential, gives you in this idea the interesting rotations. For example, here we have 2 plus 1i, so squared would be 4 plus so let me remember this formula is a plus b squared equals a squared plus 2ab plus b squared. So in our example it would be 4 plus 2 multiplied by 2 but I plus I squared, which is minus 1. 4 minus 1 is 3 plus 4i. If maybe I miscalculated it somehow, but probably it's 3 plus 4i, so it's here 1, 2, 3, 4. So this dot goes here. Anyway, I hope you understand the idea, and if you want a more clear explanation, because I know I explained it's very messy, you can go into this very nice site, and it's also a film made 10 years ago, and the manual it was translated in many languages. It's called Dimension. I really recommend it to see it, to watch it. But in chapter 5 of it, there is the chapters 5 and 6 about complex numbers, and it explains this idea in more detail, and it gives you different examples and how it can be represented as images. Okay, so let's back to TouchDesigner from Paint, because nobody likes Paint. Let's dive in, and this is GLSL. But again, if you don't know GLSL at all, don't be afraid, because the code is very simple and you actually don't need to know how to code. Let me switch to another image, because yeah, this rotating myself, it's not very pretty. Okay, this is my Patreon subscribers, supporters, and if you wanna be one of them, I would be very grateful, and you will have some extra bonuses and for this tutorial as well, and I will back to it a bit later. But now let's see. Here is the core part. I called it complex. It's the GLSL top, and we have two main GLSL dots. one called, this file would be available for everyone. So you don't need to be my Patreon subscriber to get it. Okay. And this GLSL consists of two shaders. One is preprocess directives or some functions, and it consists of all functions you need to calculate these complex functions. For example, so it represents basically the complex number as two-dimensional vectors, and do all mathematics that necessary for calculating complex tangents, complex cosinus, sinuses, powers and exponents, inversions, multiplications, and so on and so on. And you don't need to change anything in it. And it's not me who did all this magical math. It was taken from shader by Ricky Reuser. So probably he's calculated all those functions. Okay, and this is a little bit of code that I wrote to play with this idea. Let me turn off the effects I have and start from 0, and I will in this kind of approach it's very important what kind of extend mode you set, because if you set mirror it gives one result, repeat gives you different result, and 0 gives you another result. So every time you could play with this extend mode and get different results. Most of the time I work with mirror, but to show you how it works I will better start with 0. And let me make this top non-squared like this one, because I want to show you important thing in code. And again, you will get this code. Don't need to retype it by yourself. Here in the main function I have two strings. What would you start from? And you have two options. You need to choose one, so one should be uncomment and another one comment. Here I have an option for input aspect. So if you have like 16:9 aspect ratio, it will stay the same. But most of the time when people work with complex functions and this conformal transformation, they start from square. And here you have a function, so you don't need to crop and make it square by yourself. But if you do this stop not from video as I did here, but from text or somewhere or something else, it's even better to start with a squared 1-to-1 top. Here I have a switch to different tops, nothing interesting here. Here I have a crop, because sometimes you want to multiplicate this effect, and recently I discovered, or actually not me, I found it in somewhere else, can't remember who and where, in some tutorial. If you use the crop top, and instead of the ordinary way when you just set a crop less than 0, if you set the crop to some number like 5, it will give you a tile like 5 on 5 or 5 on 3 or something else. And sometimes if you like multiplication, maybe not with text but with some circles or somewhere else, it's interesting idea, but I don't need it now. And here in the vectors page, I also have a couple of parameters. It's a scale parameter that you could scale your top, because sometimes it could be important. It will make very significant changes in the resulting effect. But usually it's a good idea to start with 1 or with 2. And there is also translate. I didn't translate from the center because usually I'm not totally sure why. I have some ideas but not sure. But usually the people who works with conformal mappings, they start from like in our paint already deleted. So in our imaginary two-dimensional plane, they usually prefer to start here, not here. But you can with transformation you could play with it. Okay. So, and it's also good to start with iteration equals 1, and I'll back to these iterations later. And now let's open the code, and everything happens here in this function called Z transformation. And basically it does this transformation these times in a loop. So now it does one transformation. And we don't have any transformation. We have Z equals Z, and I forgot to mention that the standard name for this kind of workflow, they call this complex number Z. I don't know where it comes from, but it's a standard notation, and so I use it. Z equals Z. And probably that's it. That's the core of tutorial, because what you want to do, what you need to do next is just experiment with available functions. And I don't really have any good advices except from just to do something and see what's going on. For example, let me put it in a square. Z square is equals 2, and voila, and we have this squared transformation. And by the way, you could always look into this complex functions dot to see what every function, how every function works, which is maybe not very important for you, but also what kind of arguments it expects, because some functions like sinus, cosinus, and so on expects from you only Z, and some like power function expect for you Z and the number for power. So if you want something squared, so the power is 2, and you put 2. And some functions like multiplication expect from you to Z, 2 complex numbers. Let's try some multiplications. Here I put a new, I just keep the old Z, the unchanged original Z, this one. And let's multiply this original Z with new Z, with our power Z. So Z equals C multiplication C Z. Voila, we have Not very interesting, but okay, this is good. And what if we not equals but added? Okay, not super fascinated, but oh, okay, this is something. And what if I switch into from 0 to mirror? Okay, this is more interesting. And if I increase the number of iteration, it should be integer. It will probably okay, right now it's not very interesting, not a good function for doing this. And what if I divide it? Okay, and iterations, not so much, but okay. So as you can see, I just play with it, and you can put a function inside a function. Function inside the functions. Sometimes you will get some fractal look like here, and for fractals it's better to switch to something else, probably like tin 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 tin. Okay, I like this one. And as I said, the scale affects sometimes. Oops, 0.5. Yeah, nice. And what if I increase the iteration? Not so good. So just play with all of that function, and let me show you a couple more tricks. If you want some dynamics, first of all, you could use, for example, uTime variable, which is dynamic variable, or you could create more dynamic variables and use it. And for example, if I add this time to my sinus, not so good, not so good. Okay, it wasn't a good idea. And if I multiply, okay, it doesn't work, so don't do this. But you could also, outside of loop, do something like z plus equals uTime, and you get some super simple animation, or zy, or zy equals zx multiplied by divided plus. Okay, so you just play with it, and probably, hopefully, after some minutes or maybe some hours, you will get some interesting result. Let me do something else. And of course you could create something called z2 equals, for example, for example, I don't know. What's wrong? Undefined variable z2. Yeah, sure. Too few parameters. Okay, this cadd wants from me what it wants from me. It wants from me probably two two vectors, two z's, and instead I put z plus z2. Okay. All right. What else? What else? As I said, you definitely should play with this mode. it would be probably better looking with this one, for example. 0 doesn't work now. Repeat makes this effect, and mirror gives you a bit different effect, and maybe decrease number of iterations. As a general rule, it's not always the true, but usually if iteration equals 1, if you have one iteration, this kind of effect, it's very good to make some kind of warped mirror effects and something when you want to have your image recognizable. So it's very good for the camera input. And if you have a lot of iterations, it usually gives you some fractalic look. So if you're interested in fractals, choose a lot of iterations, and probably you should start from maybe even just constant. Let me make it bigger. Yeah. And yeah, for sure you could also animate not in the code, but you could animate this top, like using noise instead, and so on. What else? Let me back to one iteration. What is this? What is this grid? This grid, it calculated in the end of code. I don't need to understand this, but probably if you saw my last tutorial about the vertex shaders, you know this function, and this function gives you a smooth transition between the borders. And I have how it's called, it's render select, or in this case it's GLSL select. And if you like this, if you like to have these borders or maybe even bigger borders, you could use this top, and if you don't need any borders, use this. And sometimes, which is very strange but interesting stuff, if you set the borders 0, 0, in this case it looks the same, but sometimes, especially if you have not like 4 lines but many lines here and a lot of iterations and a lot of stuff going on, sometimes even if the border sets to 0, these two tops gives you a little bit different results. So it's nice to have them both and choose whatever you prefer. And another good trick to you is we have functions called cinv, so inversed space or inversed number. And if you experimenting, if you don't know what you want, it's kind of good to try inversions from time to time. So in this case, inversion doesn't give you anything good, but maybe sometimes. Okay, in this time it doesn't work, but sometimes this inverted version gives you a better result. Okay, doesn't matter. Boom. And the fractals, let me give you a super simple example. Maybe you recognize it. Z equals, so Z squares plus C, so plus original Z. Okay, and if we increase the number of iteration, you will get something familiar. Probably it's familiar to you. Let me switch back to this version. So it's Mandelbrot fractal. Usually for Mandelbrot, you could Google it. Mandelbrot set. So here the explanation. Mandelbrot is z squared plus c. Z squared plus c. All of fractals are very, not all of fractals, but some of fractals very connected with complex numbers, and you can found different famous fractals like Newton fractals, Julia set, and different sets, which is also possible to create with this technique. But usually Mandelbrot visualized this kind of way instead of this kind of way. So the color should be outside, not inside. And this is done in a very different, not very different, but somewhat different way. And if you are not the super GLSL beginner, and if you know a little bit of GLSL, it could be a good exercise to you to understand how do you need to change this code to get such kind of result. And on Shadator and everywhere you could find a lot of examples how it's usually done. So I recommend you to do it as exercise. It will require like 3 or 4 lines of code here, because in such kind of coloring, the coloring is calculated inside the loop, and of course this line should be changed, because in Mandelbrot you don't use a texture. But you don't always need to colorize the Mandelbrot in the standard way. And yeah, let's back here. And if you one of my Patreon subscribers, if you not my Patreon subscribers, you will get this file with all this code, so you could explore it by yourself. And if you one of my Patreon subscribers, you will get also this container, which has 5 examples how you could use this, how you could use this technique to create such kind of visuals. It's mostly to inspire you to try very different things. I particularly like this one. I just come up with it in, I don't know, some means of experimenting, and it creates a very different result from usual, because usually you will get something how to describe a wavy, liquidy stuff, but you could also get something like how it's called, broken mirror effect, kaleidoscopic effect. And also in my Patreon subscribers, you have a different I experiment with color in Mandelbrot, and here, as you can see, I don't have any textures connected, and colors is calculated from distances. It's not the same as normal Mandelbrot, but another inspirational stuff. So do I have something else to tell? I don't know. And thank you for this nice Patreon subscribers, Patreon supporters, and yeah, and probably that's it. So see you next time, and next time probably it would be a tutorial part 3 of remarch series. But maybe I will again would be distracted by some mathematical beauty of somewhat. And once more, I recommend you to see this YouTube series and read this maybe if you like mathematical fantasies, mathematical kind of stuff. And it also can give you a different ideas what you could do with this technique. As some formulas you could try to insert in our code. And it's very nice, really nice video. And they also have another one about chaos. About chaos. Also many interesting creative coding ideas, like cellular automatas and strange attractors and other stuff. Oof. Okay, that's it. Goodbye. And please, if you if you would experiment with this technique and this file and you get some very interesting result or mildly interesting result, please tag me on Instagram, because I'm really curious to see what you could come up with this, because it's super versatile technique, and probably I'll explore. Me myself found only a fraction of different looking styles and different possibilities. So I would like to see what you got. Okay, goodbye. See you.